Hey, what's up everyone, and welcome to the very first live coding session on this channel. In today's video, we're going to create an awesome app using Python that can search for and identify similar faces. So get ready to dive deep into the world of facial recognition and learn how to harness the power of Python to make your own cutting-edge app. So grab your favorite beverage, sit back, and let's start coding. So the idea is quite straightforward. So I've got a photo of a person and a couple of videos, and I would like to identify a person on those videos. Looks like a complicated stuff, but fortunately there are a lot of Python libraries and packages that allows creating actually this kind of application in not so many lines of code. So let's start from scratch. I've got nothing prepared, and we're going actually to, well, as the title suggests, we're going to code in the real time. So I'll start with by creating an empty folder. Well, let's call it rookie video, and I'm going to open this folder in my terminal. Actually, just for those who don't know, we can create your own shortcuts. So I've created a shortcut on my Mac to be able to open the terminal, to be able to open the folder in the terminal, and in my case it's Command Shift E. And this is actually great because I've got Visual Studio Code installed and nothing else. Like I didn't install anything else, so only Visual Studio Code, because, well, I love using such kind of minimalistic solutions. And of course, I also used PyCharm, but for this very project, we're going to use Visual Studio Code. So I've got my folder, and let's create an empty Python file that I'm going to call video, maybe facial recognition.py, and this is it. But first of all, well, as I'm going to process image in 99% of cases, you will need to install an OpenCV library. Actually, I'm always confused. I can't remember whether it's Python OpenCV or OpenCV Python. So let's start with OpenCV Python. I do believe it was like this. No, it's Python OpenCV. Okay. Nope. So it was, yeah, just let me just have a look. Yeah, I'm constantly confused because I just can't remember. It's impossible. So py OpenCV Python. So it's OpenCV -Python. So it's pretty weird. I actually should be able to install it. So pip install. Let's, for instance, try with the NumPy library. So seems to be working fine. So pip3, and I forgot. So OpenCV, yeah, it's OpenCV Python. So OpenCV Python, come on, pip install. Oh, my bad, I forgot the word install. Yeah, and also there exists an awesome library which actually is quite useful in anything concerning the facial recognition. Of course, Python has a lot of predefined models that allows actually. And if you're familiar with OpenCV, so there are lots of example tutorials on the internet that allows you actually to identify faces. Well, in almost no lines of code, just in a couple lines of code, you're able to identify. And in most of the cases, you're actually using the hard cascade classifier. This is an XML, is the model compressed in an XML format, and you're using this cascade classifier. But the problem with this is actually that there are a lot of false positives when you try to identify the faces, and besides actually, because we're looking for similar faces, because and this is besides actually analyzing, detecting the face, I'm also going to analyze the the facial details like mouth and nose, eyebrows, all the small details that may be crucial for identifying the person in a video. So this is why this library is called face recognition. Just let's have a look. And this is it. I do believe that is this library, yeah. And you see, which is actually great, that it allows you identifying the facial features. And this is what we're going to use to be able to identify a person. And as I'm using Mac, so there is no need in C++ compiler, but I do believe that Windows users, as far as I remember, they will need to install a C++ compiler to be actually able to use the library, because besides this is a Python package, indeed the library has been written in C++, and Python is just a wrapper of this C++ program, nothing more. Well, so I'm going to install face recognition. I do remember, I do believe that this was like this, yeah. And this is it. Well, for the libraries, well, and unless I'm mistaken, by now there's nothing more that I need to install. But first of all, let's actually try just reading the video and nothing else, because, well, I usually start small and I do not plan to create anything complicated just by now. And that is why I'm just going to use create a simple program that captures the video from a file. Well, yeah, first thing that I need to copy a video. So I do believe that I had a video in my downloads folder. Yeah. So I'm gonna paste it here. Oh, it does work like this. Oh, my bad. I thought it was supposed to be working like this, but no. And so video capture, and if you know OpenCV, so you know that there is in almost all the cases when you process the real time, anything in real time, so you need a video capture class, and which actually reads the video feed as a flow of frames, and we're going to read the video frame by frame. Well, unless it is not this complicated for a program, because, well, actually the facial recognition itself is a heavy process. So by now we're not going to do anything special about this. Just create a simple while loop. Right frame. So video capture read. Yeah, I guess so. If you know, so if you put video capture and you put 0 here as a parameter in the video capture class constructor, it will read the video from your camera, and it's actually great because you can also create an application that is able to be plugged into a real world application, like for instance, I don't know, maybe a camera feed of a supermarket or something like this. And so by now I'm not actually going to process anything on the here in my loop. I'm just going to show the video feed, and so I'm just going to show the video. So I need to create, and this is the first thing I need to do, I need to create a constant, and I need to create a window name, and let's call this window name face recognition, facial maybe, facial recognition, and I'm going to show it. So it's gonna be window name, and actually I'm going to show my frame. And so you may have noticed that I'm reading red and the frame because the result of video capture review is a tuple, and in the tuple there is a red and a frame. I actually don't remember what red is, what does red actually stand for. In most of the cases people actually create a read the video capture like this, so creating a variable that's not going to be used, but let's call it like this just to avoid any problem while reading the code. And in the terms of clean code, I'm not quite sure that coding like this is a great stuff. So let's actually create a variable that means something. So imshow, and I'm also going to create a wait key. So it's going to be wait key 1, and so you're going to 0xff equals order q. And I'm actually gonna, so if there is a if I press Q, is gonna stop the, is gonna break my loop, and consequently it's gonna actually stop my program. And to make my program stop, I'm actually going to release my video capture. It's gonna be released, and I'm going to destroy all the windows, so to be able to reuse them when I rerun the program. So it's gonna be destroy all windows. So let's give it a try. 3 facial recognition. No. There's no wait key. Oh, here's my bad. Yeah, it's wait key with a K is a capital letter. Yeah, it seems to be working fine. So as I've noticed, I've grabbed the Big Bang Theory video, and this is actually great. Okay, so by now everything is working fine, but we have not actually implemented anything special. Just a very simple for loop that rates a video stream, a video feed frame by frame. But this is what we need, actually, the frame itself. So we're going to process the frame to be able to extract the faces similar to a given face. And in our case, let's say I'm going to detect the actually if there are Jim Parsons in the scene. So I'm going to look for Jim Parsons photo in Google Images. So this seems like a great photo. So let's just download the photo and save it. Save image as, and I'm actually going to save it inside my rookie video folder. And let's say it's Jim's. So it's Jim, just Jim, like this. Okay, so I've got my Jim JPEG file. This is great. And this is actually when we start encoding the face and actually start developing our real application that is going to recognize the faces. And well, first of all, we're gonna import the face recognition library. So it's not facial recognition, it's face recognition let me give it a try just to be able to just to be sure that the import is correct. Yeah, so the import works. Sorry. Yeah. And well, I've got my video capture, and also, well, just window name just after the import, so because all the constants. Let me just create a couple of constants for different colors. And just, if you remember, in OpenCV the colors are in BGR format, so it's not in RGB, and this is why like for instance red is gonna be, so is it BGR, so it's 0 0, and red is 255. Green is so the green is B0 green. Green 0 to 255 and 0. Yeah. So, and this is it. And once when I've created my video capture object, so let me create my gym image. And this is actually important because I'm going to load the Jim Parsons photo as a face recognition object, so as a face recognition file. So I'm gonna load image file, and you should know that the file itself is actually well, when it is right into the program, so it's in a specific format. It's not like OpenCV, so we'll need to make some kind of wrapper to be able to convert from OpenCV format to a format that is compatible with face recognition. So first of all, load image file and say JPEG. Just let's test it. Yeah. By now there is no error. We're actually doing great, because well, by now we've had only one bug here at white key, but except this, nothing. So, and I'm also going to create a gym face encoding, and this is the key points. So I'm going to encode Jim Parsons' face to be able to compare the vector to all the vectors, to all the facial vectors extracted from each frame, and so on and so forth. So again, so it's going to be face recognition, face, there is a face encodings function, and I'm going to put gym image into it, and I'm going to extract only the first value, because the first value which actually corresponds to the gym face encoding. I can't remember what the second value is for and the other values, but I do remember that the very first value of this face encoding is the first value. So is it the actual encoding itself? And let me create an array of my known faces, like known face encodings. And let me put gym face encoding into this array. So looks great. And actually I'm also going to create, well, known face names. I'm going to create an array of all the names, because, well, sorry, even if it's a match, so I need to actually to identify the person, and I also just, well, I need to create a kind of pointer to be able to extract the name, and I'll call Jim, just Jim, or maybe Jim Parsons. Yeah, looks great. And well, after that, I'm going also, because, well, how actually I'm going to be able to to draw rectangles around each one's face is because with the locations. So this is why I'm going also to create an array which I'll call face locations, face encodings. Well, you'll see later why I'm doing all this. Face encodings, face names. This is actually a temporary array that I'm going to use, and I'm going to populate inside my my for loop. Well, and actually this is it. So let's just by now verify whether everything is working fine. So facial recognition, yeah, it seems to be working fine. So sorry. And actually, as I said before, there is a special format which is not compatible with the OpenCV format. So this is why I need to import a NumPy library. And actually, I found this this tip on Stack Overflow because I was actually struggling when I was passing the frame inside the facial recognition, into the face recognition library, and I found this tip very useful. And this is why we are going to create a function which we are going to call adapt image, and here we pass our OpenCV frame. I can't remember whether I've installed the docstring extension. Yeah, and this is, well, actually quite useful because, for instance, if you're working with someone on the project, so it's gonna be useful. And this is why, well, just return frame. And for instance, if someone is going to reuse my function, so I'm going to call adapt the image of the OpenCV frame, an OpenCV, so because any OpenCV, so in an OpenCV frame for facial recognition. And well, my frame, the type is, well, actually it's also an ND array, I guess, but it's in an OpenCV format. So this is what I'm going to say, OpenCV image, and returns, well, it is also going to return an PNG array. Well, I may be mistaken, but at least I've got a documentation, so I can correct it further. But I do find it's important to generate docstrings for importing functions. Not any function, but at least a function that is going to be reused. A continuous array compatible with face recognition. Okay, and here the trick. Well, first of all, I'm going to reduce the size of my frame because, well, image extraction is a quite heavy process itself. So reducing the frame size is going to be well, quite useful. So I'm going to resize. I'm going to resize my image, my frame, and well, this is quite. I forgot the signature of resize. Well, there's a problem with my Visual Studio Code. It doesn't recognize the libraries. Well, this is not this important because, well, I do remember that there is a fx, so I'm going to resize by x to 25%, and by fy, so actually by y by well, to 25%, well, because I'm going to resize it by 75% and leave only 25%, so this is great. And yeah, as I said before, so OpenCV image is in a BGR format, and also I need to convert it to RGB, but there is a function in OpenCV which actually converts, which is CV to convert CVT color. I do remember it was like this, but it doesn't work with this library. I don't know why. So this is why I need to convert it to a continuous array, a NumPy continuous array. And this is why. So I'm going to convert it to RGB format. RGB small frame equals to NP as continuous so continuous, so a contiguous array, contiguous, well, I'm not sure of my, yeah, import numpy as np and as contiguous array, and I'm gonna, yeah, put my small frame in here, and here the trick. So this trick I actually found on Stack Overflow, so kudos to Stack Overflow community for finding such a great workarounds. Yeah, and it seems to be working fine. So I need to return the RGB small frame, and just let me have a look. So adapt image, and inside my for loop, I'm going to adapt my image. So adapted, let's call it adapted frame equals adapt image and my frame. If it works, if it works, so this means at least we don't have syntax error. Yeah, by now everything seems to be working fine. Okay, and also I will need, so if as I resized my image by 25%, I will also need to multiply when I will draw a rectangle around each face. I'm going to multiply the width, and the height by 4. But well, let's keep developing and we'll see further. So so what to do next? So I've got my adapted image, and and I'm also going to initialize actually my array. So face location and face recognition library has face encodings. And besides, actually, so because we also get face encodings in here, but besides, oh yeah, I do remember why we're using the 0, because, well, face encodings actually returns an array of encodings, and as I'm only encoding one single image of one single person, so this is why I only need to the first person, because, well, we don't have a lot of persons in here, so this is why. Okay, so I'm going to encode the faces. Well, first of all, actually, I'm going to, yeah, it's not face encodings, my bad, it's face locations, because first of all, I need to identify faces. So face locations, my adapted images, my adapted frame, sorry, and this is it. So let's just actually try to identify. So frame face locations, whether it recognizes the faces or not. Okay, so we've got some faces in here. destroy all. So it's not destroy. Yeah, it's destroy all windows. So face locations from my adapted image, it doesn't seem to recognize any. So oh no, it recognized actually, because yeah, I do remember, because at the very beginning there was an introduction to the video, so there were no faces in here, and here we've got some faces, and if you remember, so we need to adapt the faces. So just let's give it a try. So we've got face locations, and let's us create a simple for loop and here we've got the top, the right. So according to the documentation of the library, so I'm not taking this values out of a head. So for top, right, bottom, left, and face locations. So I need to multiply each value because by 4. If you remember, I've resized all the images. So yeah, so it's top, it's right. So I've got a better idea, I guess, or not. No. So it's still 25%, and here I'm just going to multiply it by 4, and so bottom is multiply, because well, the idea was actually if multiply by 0.25, so I could have divided it by 0.25, and it is actually equivalent to multiplying it by 4, and so 4 bottom and left is also multiplied by 4. Okay, and let me just draw a rectangle. CV rectangle. On my frame, so using left and the top, and right and the bottom. This is actually great, and I'm going to put let's put a green color around each face. Well, maybe red, because well, by now I've not recognized any face, so let it be red, and put me to the thickness of my rectangle. Okay, and well, and this is it, so it should be working. Well, yeah, and let me rewrite the function after. Yes, so as you see, so there are some faces that have been recognized. So not all the faces, as you see, because well, I'm actually reducing the size of my frame by 4, and this is why actually when the frame is too small, so the software is unable to identify. Just so let me actually try whether it's slower or not if I do not resize the image. So instead of resizing the frame, I do nothing, and yeah. So maybe I should keep it right there. Small frame instead of calling it small frame, I need to also just only to rename it. So frame is equal, and also well, RGB frame. Well, let me keep it because it's gonna be confusing. So I'm just keeping it like this. So frame. Yeah, I'm converting it, and I'm not multiplying I'm not changing anything. Okay, and let me see whether the faces are better recognized or not. But you see, it's much slower. But the facial recognition is supposed to be so much better. I'm not quite sure. I'm guessing. But the so if you see the performance dramatically decreases. No, neither. It's not working much better. So this is why this workaround is actually very useful because, well, let me create a constant value. So let me put it this way, just after the import, and let me create a variable which will be called resize, reduce rate, and yeah, and this looks so much better because I'm actually gonna reduce, define the reduce rate once without actually to have to change it everywhere. And from the point of view of clean code, this seems so much better. And here I'm gonna actually, instead of multiplying, I'm just going dividing by reduce rate. So when I divide it by 0.25, it should be multiplied by 4, unless I'm mistaken, because, well, it's been a while since I've not done any arithmetics, but it should be working fine. Just let me verify. Nope, no way. Sequence has the wrong type. And if I just multiply it by 4, just in the same manner as I've done before. Well, it seems pretty confusing to me. Okay, I see, because the value itself is not rounded. This is why. So reduce rate, and okay, let me create a function. So once I've adapted an image, I'm going to adapt the coordinates, and the coordinates is actually face location. So let me create a single face location, and the face location is like this. So for top, bottom, left, and let me call it like this. So top, bottom, top, right, bottom, left is the result of my face location, is a tuple, and I'm just gonna simply change the values in here. And so my multiplier is, well, I see the problem, because when I multiply, so it's converted automatically to float, I guess. So multiplier is going to be equal to int and 1 divided by reduce rate. So if I divide 1 by 2, let me just double check, because I'm a little confused. So it's 1 divided by, it's not plus, yeah, 1 divided by 0.25 is 4. So the arithmetics is correct, but just, yeah, I guess this is just simply the integer value that is, well, actually was problematic. And I'm going to just multiply by multiplier, and I'm going to return the values just in the same manner. So like top, right, bottom, left, and give it a try for top left bottom in face locations in adapt coordinates, and I'm gonna adapt them and just draw a rectangle around the value. So let me verify. Well, around the face. Also expected 4 got 0. And if I do this like this way, so the coordinates are, yeah, the coordinates are wrong. And why does it seem to be working fine? Okay, so for top right, they've got in face locations. So H, yeah, I should have done it this way. No, well, it's not, yeah, no, definitely not, because it is not quite Python way. So top right, bottom left. Okay, so yeah, it's like, it should be like this for face location and face locations, and I'm gonna pass the value inside. So it should be like, top right bottom left equals adapt coordinates and my face location. Yeah, it should be working right now. Well, I do believe. Yes, it works, and it's so much clearer right now. I'm so happy how adapt the face recognition output after resizing. Face location is a, so it's a tuple, and it should be top right bottom left, and the return is also a tuple, and again the same manner. So I'm gonna just copy it and paste it here. Okay, so steadily the code is becoming so much cleaner. So right now I'm going to, so let me just double check if it works as expected. Yeah, definitely yes. So let's just switch to the facial recognition itself, just to the detection of similar faces. So why do we need face locations? Because we'll need to well, first of all, to be able to draw a rectangle around each face, but also to pass these face locations as a parameter into my face encodings. So let me populate the face encodings array. So it's gonna be called face recognition. Well, face recognition, because there is a function that I'm gonna call, so face encodings. My adapted image, is it adapted image or adapted frame? Yeah, adapted frame, sorry, because I forgot. So it's my adapted frame and my face locations. This is great. So face encodings, it's populated, and face names is gonna be like this. So I'm gonna actually to reinitialize. I'm going to reinitialize my face names array, And for face encoding, in face encodings, I'm going to look for matches. So matches are face recognition. Compare, there is a function actually, compare faces. And I'm going to compare the faces, so known face encodings against a face encoding that I actually detected. And the name by default is unknown. And also I need to calculate the face distances. And the face distances are face recognition. And there is a function to calculate the face distance. And I'm going to calculate the face distance between my known face encodings against the face encoding. And so what should I do next? Okay, so once I've got my face distances, so I'm going to detect the best match index. And so the best match is actually the closest face, and the closest face means actually that this is the distance of the is the closest, so face distances. And so if there is a match, so let me best put the best match index into here. So name is gonna be equal to known face names. Well, because there is the correspondence between the, as you see, my face between my known face encodings, and known face names. I need to identify the name of a person. So best known face names, best match index, because the index is the same. And face names, I'm gonna append the name. Okay, so once this is done, so I need actually also to add the name in my face location. So I'm put the name, but also I'm gonna zip my face locations together with my face names. That's great. And well, once I've drawn a rectangle, so this is a red, and okay, so I'm gonna put it some text. So it's gonna be cbt put text. This is my frame. This is my frame. This is my text. The text is my name. Put text, and let's just add some margin, just not to be, or maybe not. Okay, so it's gonna be left and bottom. The font, well, this is actually great because I should have created a font. So let me create a font, and by default let me put a font which is called font Hershey Duplex. There are not so many. As far as I remember, there are only 6 fonts available in OpenCV. So there's not much thing to. There is not much fonts to select from. So so I've got my fonts. No, not like this. Font as a constant. So I've got my left bottom, my fonts, also the thickness, and the color. And the color, let me I'll add the color after. So it's a line type. I guess it's a line type is 1, and the thickness is 10, or vice versa. I can't remember. So because I don't remember by heart. So facial recognition. Jim Parsons. Oh, that's great. So we've got Jim Parsons, and also we've got some unknown face. So Kelly Cuoco, but the program doesn't know her name, and this is great. So it's shown as unknown. Okay, this is actually great because we've succeeded to identify the person. Well, let's make our code a little bit cleaner. So for instance, we've got red, green, and also let me add white. The white color is the simplest because it's just all 25, because the white is the most complete color. Oh. And also I do know that there is a way to improve the performance of our program. So first of all, so the font is good. Left bottom font, one green, 1 red. So it's gonna be white. Yes. But besides that, so we say that in any cases the color is red. Oh, maybe it should have been green when the person is actually identified. So let's make the text white and change the rectangle color whenever there is a match. So just let me check how can I populate the so implement it in the code. So we got face locations, face names. Well, actually, I don't think that we need this array. So let me give it a try. Yeah, so they are completely redundant. Okay, so we've got known face encodings, known face names. We've got our frame, we adapted it. So we've got our face locations, face encodings, face names, for face encoding, so matches, compare faces, known face encoding. So for the print margin, because if you know, so there is such a thing as a print margin, I guess we're all right. It's about 80 characters or something like this. So to make it actually easier to read and to understand, okay, in our case, everything seems to be working fine. So face locations, face encodings, and so we identify them. And for face encoding, we are looking for a match. We create, so the name by default is unknown. So we get face distances, if match, so name is the corresponding name. And it seems like I could have wrap everything in this part into a function, but beforehand, let's actually add some logic in here. So for top, adapt coordinates, face location, and let's say by default the color is red because we have not identified the person. But if name is not equal to unknown, So the color should be green. So let's give it a try. Yeah. And let's try with another face. Okay, this is unknown. Well, I do love it because it works like a charm. So let's face name, because the result for us the face names, because the face locations is already known. So let's create a function which will return the names. Def get face names for face encoding. For face encodings, matches, compare faces, known face name is equal, face distances, known face encodings, best match index, matches. Are there any compare faces, known face encodings? Known face encodings are here, but at the moment when we call it, so it should be face names append. Okay, so no, there is no way, or maybe there is a better way, but right now I don't see any way to wrap this into a new function, because we've got face names. Or maybe that's a good idea, because I can actually create the face names. So what should I pass inside my function? So I need to pass the face encodings, and for face encoding, so matches, but I also need known face encodings and known face names. So this is the key. Okay, I see. So I need to create another function, so which call it get names, get face names. Face names is going to be equal to face names, so for face encodings and face encodings. So the first thing I need to pass inside this function is the face encodings, but also known face encodings, and so the name is going to be equal to unknown, but let me put it there. So face name is equals to unknown, face names, name is unknown, known face encodings, and also known face names. And this is it, I guess. And we need to return, so once for face names, and we return the face names. Just there is no specific reason to do this, but I like it because it makes the code so much cleaner. And well, we create face names in here and get face names. So we have face encodings, known face encodings, and known face names, and it should return now as the face names. Okay. Yes, it works. Oh, this is great. I do love when it works just from the first run. So our code is so much cleaner now. Let me generate a doc string. So get the corresponding face names for matches, face encodings, and known face encodings. Known face encodings is an array, so it's a list. Known face names is a list too. and this is a list 2, because, well, just to make the compiler understand that this is a, well, not the compiler but the other developer who's going to read the doc string, that this is an iterable. So face encodings, an array of face encodings generated by face recognition out of pictures and known face names is string, an array of strings corresponding to the picture names. Okay, and we return the list to well, great. This works. So the name is now unknown, so color is green. And as I said, so let's double check. Yeah, it works. And I said there is a way to optimize, and I guess that this is actually the case because, well, we're gonna read only the 50% of our frames, so not each frame, because, so let's check once more. You see that it's not as fast. Maybe it may be faster. And for this, I'm actually going to create a counter. So beforehand, so I'm gonna create a counter, set it to 0, and while true, so after each im show, I'm going to increase the counter value, so it's going to be counter plus 1 plus equal 1. And why I'm doing this, because I need to identify each second frame, not each frame, because analyzing each frame may be quite heavy for your processor. And this is why I'm gonna actually analyze only half of all the images. And how can I do that? I can actually create a verifier, so it's if counter divide, if the remainder of division by 2 is equal to 0, this means that this is an even number. So it's actually quite great because I'm gonna divide all the frames into even and odd, and each even frame I'm gonna analyze with a facial recognition library, and the other frames I'm gonna leave. And this, in theory, it's gonna increase my program performance because I actually don't need to analyze each frame. And if you see here, it's quite great because though it's so much faster. So it's unknown, like just. Okay, there is something that I forgot because I'm gonna draw the rectangle and I'm gonna put the text in any cases. Oh, this is why I'm actually, yeah, there is gonna be a problem because my library, yeah, so the left is not defined, and this is why. Yeah, but still it works fine. So I need actually to identify the so if there is no face recognized, so by default my left, right, bottom, top should be equal to 0, and this is why adapt frame, face locations. Okay, so maybe I should put it here. So I'm gonna detect face locations in any cases, but only for certain frames I'm gonna analyze the image. So if counter, so face locations I'm gonna detect in any ways. So let's put it this way. Face name, right, adapt coordinates. For face location, okay, I see. So there is no way actually to, well, I could have optimized, but so there is a better way actually to creating a logical variable. Yeah, now I see. Now I see the reason why we should have created actually a global variable with the face locations, but right now everything seems to be working fine. Yeah, it works. So let's add another person's. So the second person is Kalikuako. I can't actually remember. Is it K or C? I'm sorry for that. So it's C, and so it's Kelly. So not Kelly, it's Kelly. And let's just grab any image, or like this. Save image as, and I'm gonna save it as Kelly. Okay, and I'm gonna actually add in another face encoding. So I've got Gym image and Gym face encoding. And also let me add Kelly face and Kelly face encoding. It's gonna be like Kelly. Kelly image, Kelly face encoding, load image. It was, I can't remember what it is. Is it JPEG or GPG? Yeah, it's JPEG, great. So it's Kelly JPEG, and I'm gonna encode the Kelly image, not Gym image. Face encoding is Gym image, Kelly image, face encoding, Kelly image. Okay, so there are no face encodings. Let me add Kelly face encoding, and no names is, I forgot the syntax. So is it Kelly Kuoko? Yeah, it's like this. Oh, and let us verify whether the program is able to identify. So Jim Parsons, this is great. Kalikuako, yeah, it works. So the program, as you see, is able to identify. So the only person left is the actor who played Leonard Hofstadter. I can't remember his name. Well, just Leonard Hofstadter. Okay, so as you see here, so what we've done so far, we created from scratch an excellent program that is able to identify, given a photo, is able to identify this person. Given a person's photo, is able to identify this person in a video feed, and as you see, there is not so many lines of code. There is an example on GitHub, but I actually wanted to make it more clear. So this is why I executed it step by step, and also I tried making the code as clean as possible by adding some simple functions and actually splitting the whole code into a list of functions. And well, actually, there is so much room for improvement. Like there is a still way to improve the performance by analyzing each frame, but we need to just slightly change the logic. And also there is a way to make the code even cleaner, like maybe wrapping all these parts into the into one single function. I'm not quite sure, but I'm pretty sure that's possible, because well, that is a famous Boy Scout rule. You need to leave your place cleaner than at your arrival. And so we actually tried making this code as clean as possible by now, and in the next iteration we're going to make the code even cleaner. Well, I hope you found this video useful, and I hope you enjoyed the video and creating the project with me. And well, hopefully you will find all these materials useful, because well, using the example provided on GitHub is not this clear, and actually implementing the program step by step gives you a clearer vision of what is done with which purpose. So again, thank you very much for being with me. I hope you found it useful, and see you later. Bye bye.